All right, so we're going to be working with two formulas in this section. And so they look pretty similar with the exception of that one piece on the second one. All right, so I'm going to let you write those two formulas down. Leave a line or two underneath each one so that we can put a little bit of information. We'll do that in just a minute. Okay, so the formula that you pick for an OR problem depends on something that we call mutually exclusive. So I'm going to write this down and then we're going to talk about it in just a minute. So this first formula is going to be used if the events are mutually exclusive. Okay, so we're going to get this written down and then we'll talk about what that actually means, that mutually exclusive term. And then our second formula is used if they're not. Okay, so used if the events are not mutually exclusive. So the best way that I can describe to you like what mutually exclusive means is that it essentially means that there is no overlap. So what we're going to do is we're going to list out the possible outcomes for each event. And as long as there's nothing in common, no overlap, then we're going to say that they're mutually exclusive. We're going to practice this with a few examples. All right, so I'm going to go ahead and look at an example page, and we're going to talk more about what that actually means with that mutually exclusive. All right, so the example that we're doing is we're rolling a die. So we're rolling one die, so one six-sided cube. And we've got a couple of different scenarios here, and we want to say, yes, they're mutually exclusive, or no, they're not. All right, so I'm going to start with part A. And one event is getting an odd number. And the second event is getting an even number. And I want to know, are those two mutually exclusive or not? So if I think about my odd numbers on the die, those are 1, 3, and 5. And if I think about my even numbers on the die, those are 2, 4, and 6. So remember, mutually exclusive means that there's no overlap between the two sets. So 1, 3, and 5, 2, 4, and 6, there's nothing in common between the odd numbers and the even numbers. They are completely separate. So I would say that these are mutually exclusive. Okay. Now I want you to compare that to part B. All right, so the first event in part B is getting a 3. And then the second event is getting an odd number. Okay, so getting a 3 just means that you get a 3. So that's the only option there. And getting an odd number means you would either get 1, 3, or 5. Okay, these two events are not mutually exclusive because they both have a 3. All right, so does that make sense to you? Because there's a 3 in both events, that makes it not mutually exclusive. In the first example, because they're all separate, they are mutually exclusive. Okay, all right, let's look at part C. So the first event is getting an odd number. The second event is getting a number less than 4. Okay, so again, I know my odd numbers are 1, 3, and 5. My number's less than 4. That would be 1, 2, and 3. All right, so would you say those are mutually exclusive or not?
No.
No, why not?
3.
The 3, good. All right, so everybody agree with that? These are not mutually exclusive. The problem is the 3. All right, and then the last one, getting a number greater than 4 and getting a number less than 4. So number greater than 4 would be, that would be 5 and 6. And a number less than 4, that would be 1, 2, and 3. All right, so are those mutually exclusive? Those are, right? Because there's nothing in common between the two groups. 5 and 6, 1, 2, and 3, there's no overlap between those two groups. All right, anybody have a question with that? Does that make sense as far as what we're talking about with mutually exclusive?
I have a question.
Yeah.
So for D, like the greater than 4, it only had 5 and 6. That's 2 numbers. Then less than 4, it had 3 numbers at the bottom. So I thought it would have been not mutually exclusive because the greater than 4 is missing a number.
No, mutually exclusive just means that there's not a number that they have in common. So
That's not repeated.
it doesn't matter if, one set is smaller than the other one, but if there's nothing that they share, like in B and C, they both shared a 3, that made it not mutually exclusive. But in D, 5 and 6 is completely different than 1, 2, and 3.
Okay.
Okay. All right, anybody else have a question on that one? Okay, so we're going to do one more, and I'm going to let you guys kind of work on this one. This is doing the cards. So you may want to pull out your picture from your phone that you took the other day of your cards. All right, and then I want you to go through and see if you think that these are mutually exclusive or not. All right, so what do you guys think about the first one, getting a 7 and getting a jack? Do you think that that's mutually exclusive or not?
I'll say it's mutually exclusive.
You say it is?
Yeah.
Okay, so I'm going to go back. I'm going to try to find my cards real quick. All right, so 7 and jacks are what we're looking at. There it is right there. Okay, so I'm going to circle the jacks right here. And then I'm going to circle the 7s. So yes, I would agree with you that those are mutually exclusive because those are two completely separate groups. Okay, does everybody agree with that? Mutually exclusive for the first one? All right. All right, so I would say yes on this one. All right, what about on the next one? Getting a club and getting a king. What do you think on that one?
It's not mutually exclusive.
Okay, not mutually exclusive. I would agree with that. All right, so I'm gonna go back real quick and just look at the cards. All right, so we had clubs and I forgot. What was the problem? You guys have it written down, clubs and what?
Clubs and kings.
Clubs and kings. Okay, so if I look at my clubs, Nope, those are the spades, aren't they? Always get confused there. Okay. Okay, those are clubs, right? All right, and then the other one was what? What was the other one I was looking at?
Kings.
Kings. Okay, and so here are the kings. All right, do you guys see that those are not mutually exclusive because we have this card right here that ends up being in kind of like the overlap. It's in both of those groups. All right, does that make sense to everybody?
Yes, ma'am.
Okay, anybody have a question with that?
Yes, ma'am. I got another quick question.
Okay, sure.
I don't know nothing about cards, so I know that you just said that's king. I mean, that's what we just circled, the long one.
Yeah, that's
Club.
clubs. I'm thinking, yes, but all of a sudden I'm having kind of a mental block. But yeah, I mean, these are the hearts, these are the diamond, these are the hearts, these are the diamonds, these are the spades, so these are the clubs. Okay.
Okay. Can you write like next to it a little bit so I can remember?
Yeah. Or just jot down in your notes. So this is spade, clubs, diamonds, and hearts.
Okay. Thank you so much.
You're welcome. I get it. All right, so let's look at the next one. All right, face card and an ace. So when they talk about a face card, they're talking about a card that has a face on it. So that would typically mean a jack, a king, or a queen. Right, so that's what we're talking about when we talk about face cards, jacks, queens, or kings. And then this is the aces. So would you say that those are mutually exclusive? What did you say on that?
Yes.
Yes. Okay. Does everybody agree with that, that those are mutually exclusive? Do I need to go back to the cards and look, or are you guys okay with that one?
Can you go back and look for me?
Sure. I should have brought that picture up here. All right, so jacks, kings, and queens. Let me get rid of some of this other stuff. All right, so jacks, kings, and queens are here. That's one set that they're talking about. Those are my face cards. And then my aces are over here. So those are mutually exclusive because there's nothing in common between those two groups. Okay. All right, and then the last one, we've got face cards again, and we are comparing that to spades. So what do we say about that? Face cards and spades, are those mutually exclusive or not?
They're not.
They're not. All right, so let me go back one more time. All right, we have the face cards circled already. So now let me circle the spades and let's see if there's any overlap. All right, so here are the spades. So there's definitely some intersection between those two groups, right? So they are not mutually exclusive because they share these three cards right here. All right, any questions with those? Okay, so let's go ahead and let's see if we can get just maybe a couple of questions done with the probability now that we've got our formula. All right, so here's the first one. We're gonna kind of try to start easy. A box contains 3 glazed donuts, 4 jelly donuts, and 5 chocolate donuts. If a person selects a donut at random, find the probability, right? And I'm going to kind of underline what's key here. Find the probability that it is a glazed donut or a chocolate donut. Okay. So I noticed that I have the word or in the question, and it separates two possibilities, right? So I know that I've got two formulas to choose from here, depending on whether or not they're mutually exclusive. So in this particular box of donuts, is there any overlap between the glazed donuts and the chocolate donuts? So I'm thinking that those are mutually exclusive because they make a point of saying there are 3 glazed and there are 5 chocolate. They don't say there are 2 donuts that are glazed and chocolate, right? So there's nothing that's both of those things. The glazed donuts are completely separate from the chocolate donuts. So I would say that these are mutually exclusive. And so I'm going to write that formula down right here so that we can see it. The one that we use if they're mutually exclusive. So what this formula tells me to do is to basically take the probabilities of the things separately and add them together. So if we're dealing with glazed donuts and chocolate donuts, then I'm going to have the probability of a glazed donut and I'm going to add that to the probability of a chocolate donut. So that's what the formula says for me to do, is to take the two things separately and add them together. So now I need to figure out the probability of selecting a glazed donut. So first of all, how many donuts are in the box altogether?
Three.
Okay, there are 3 glazed ones, right?
Mm-hmm.
How many altogether?
8.
Let's see, 3 plus 4 plus 5.
Oh, I didn't know on the jelly donuts. I thought we were just doing glazed and chocolate.
Yeah, no. So on the bottom number, you're going to do all the possible donuts. So 3 plus 4 plus 5 is going to give me 12, I think, right? And that's going to go on the bottom. Okay, so the probability that I pick a glazed donut out of that box, there are 3 glazed ones in there. There are 12 donuts altogether. All right, what's the probability that I pick a chocolate donut out of that box?
12.
Okay, there are 12 altogether. How many of them are chocolate?
5.
5, good. So 5 out of 12 are chocolate. Now remember, when you are adding fractions together, as long as they have the same denominator, the bottom parts are the same, you just add the top parts. So 3 plus 5 is 8 over 12. Okay, and I want to reduce that. 8 and 12, I could divide both of them by 4, or you can reduce it on your calculator, either way. All right, so 8 divided by 4 is 2, and 12 divided by 4 is 3. All right, anybody have a question on that one? Okay, so let's try another one. All right, so at a political rally, there are 20 Republicans, 13 Democrats, and 6 independents. If a person is selected at random, find the probability that she is, and again, I'm going to kind of note what we need to pay attention to. Find the probability that she's either a Democrat or an independent. So we see the word or in the question, and it's separating two options, Democrat and independent. All right, so I first have to decide if these two things are mutually exclusive. So most people are not a combination of these things. Like most people are either Republicans or they're Democrats or they're independents. They don't say, when I say to somebody, what's your political party? They don't say, oh, I'm Republican and Democrat. So I don't think there's any overlap here. I think people are one category or but they're not two categories at the same time. So I don't think there's any overlap between these two groups. So again, I would say that these are mutually exclusive. All right, and so I'm just going to jot that formula down one more time. And so again, this formula means that you're going to take your two things separately and add them together. So we're going to look at the probability for the Democrats, and we're going to add it to the probability that someone is an independent. All right, so what would you say the probability that someone is a Democrat is? Does anybody have an idea for that first fraction?
13/39.
Okay, yeah, that looks good. So there are 13 Democrats. They tell me that, so that number is going to go on the top. And then the 39 is going to come from adding everybody together, right? So 20 plus 33 plus 6, that's going to give me the 39. Okay, what about the probability that we have an independent?
6/39.
Good, 6 over 39. And then again, remember that if you're adding fractions, you want the bottom parts to be the same, and then you just add the tops. So 13 and 6 make 19 over 39, and that's not going to reduce, so we'll leave it just like that. All right, does anybody have a question on that one? Okay, so let's do one more.
Can you go back?
Yeah, I can go back. Okay, so let's look at this last one and then we'll finish up with that. All right, so a single card is drawn at random from an ordinary deck of cards. Find the probability that is either an ace or a black card. Okay, so again, I see the two events and it has an or in between. Okay, so I know that I need to think about whether my events are mutually exclusive or not. I'm thinking that these are not mutually exclusive because I have aces that are black, right? The 4 aces in the deck, if you look at your card picture, the 4 aces, 2 of them are red and 2 of them are black. So we have an overlap between these two events. So if they're not mutually exclusive, I'm going to need the longer version of the formula. Okay, so I'm going to write down this formula here so we can see it. And then I'm going to translate the A's and the B's to the words in the problem, the ace and the black card. So the beginning of the formula works the same as the other one. So we're just going to do probability of ace plus the probability of a black card. And then this last part just says to put your two events with an and in between. So this is going to be ace and black. All right, so I know that when I'm dealing with a deck of cards, everything's out of 52 because there are 52 cards in the deck. So I'm gonna go ahead and do that on the bottom so we don't have to worry about that. All right, so look at your card picture for me. And somebody tell me how many aces there are in the deck.
4.
4, good. All right, and then how many black cards are in the deck? I'm gonna count that. I think it's 26, right? Half of the deck is black. All right,
It's
so
20.
go ahead.
Yes, it's 26.
It's 26, okay. All right, now I need to know, and this is a little bit tricky, but I need to know how many cards are aces and the black at the same time. So how many of those aces are also black?
2.
2, perfect, okay. So like I said, pull your picture out because it'll help you to see it. You can see that there are 2 aces that are black. All right, so let's add and subtract on the top. So 4 plus 26 is 30. Minus 2 is 28. Okay, so I'm just doing that math on the top, still keeping it over 52. All right, and that fraction is going to reduce to 7 over 13. So they're both divisible by 4, which will give me 7 over 13 for my final answer. All right, any questions there?